It's I. It's going down, but I'll survive.
No, you'd survive. Yeah, you'll survive. You got this. So,
Can you
the,
still hear me?
yeah, I can hear you.
Mm,
Can you hear me?
Hello?
Hello, can you hear me?
Yeah, I can hear you.
Well, what's going on on that side?
Every time I try to use my headsets, they don't want to connect. I have to use my speaker.
Uh, just use the speaker, my sister.
Yeah, clearly it's not working as
Yeah,
please.
yeah.
Right.
You should learn to leave things when they're not when they're
When
not
they're not
working.
working out.
Yeah, leave them. Don't force. Don't stay there too long. That's free
Yeah.
advice.
All right. Yeah, no, it's fine. We can continue.
Okay, so we're done with variables, right? Like
Yes,
took it
completely.
talking about console and what.
Uh-huh.
So let me just say this is our second session, right?
Yes.
Yeah, so I'm just gonna I think I should also normalize sending you the code even though might not, but then it's just if you wanna look at the code.
Exactly. Just to go through it again.
Yeah, so we talked about yeah, let me open this thing because I want us to go back to something very important to talk about something very important, which is pointers.
Yes.
So open existing diagram. I think this one should be the one, yeah.
Yes.
So this is the diagram, right? So what I'm going to do is I'll just I want to explain pointers, right?
Yes.
Yeah. So in order for me to explain pointers, I need to change the address here. So this is just going to be a different address, right? Let me use a different address. So let's say OX, and then 4 1s and 1F. Then this is going to be OX 123AF, right? So this obviously is going to have different names. So let's explain pointers, right? So what I would do is with the code, I'll just comment out when I'm done with that topic so that you can just remove the comments and then test it out on your own.
Oh,
So
okay.
let's introduce pointers, right? So remember what we said. We said every variable has an address where it resides, right?
Yes.
And the variable can only store a value, right? Which is
Yes.
that value, right? That the thing that's inside the box
Yes.
of that specific data type. So what happens now if you also want to keep track of the address and things like that? How do I do that? Remember that with a variable, if I say int a like this, it only stores the value. If I wanted to get the address, if you remember, I would have to say cout and then
Yeah, the ampersand.
address of, right?
Yeah.
Basically, the variable stores one thing, even though oh yeah, let me put it this way: the variable stores one thing, right? The actual value or the actual thing inside the box. What if
Yes.
sometimes the thing that we want to store is too big? Yeah,
Yeah.
I don't know which TikTok what was that TikTok trend?
Yeah.
Yeah, there's this TikTok
Trend.
trend, man, where they're saying it's very big, too big, or something like that. Yeah.
Yes.
Yeah. If it's
So
too,
it
like
doesn't
if it
fit.
yeah, if it's too big, like for example, how do I put for example, let's say a truck, right? Or a house. Okay, let's use a house example. Let's say with the house, right? You can't physically move the house, right? It's too big,
Yeah.
and there's no way you can lift it. It's going to be very heavy. So instead, we usually get the person's address, right? Then go to that person's address where they stay, because
Yes.
that object or the house is too big. So it's the same concept here. What happens now when the pointer, the value you're trying to store is too big? Let's say, for example, it's an object. We have a class. Remember, with the class, you might not see it, but then with the class, it uses a lot of space or a lot of memory, a lot of bytes, basically.
Yeah.
So we don't want to be storing the actual objects. We want to be making use of where they are located, the addresses. That's where
Mm.
pointers come into place.
Mm.
So you see this variable can only store a value. How do I make it store when do I make it store an address, right? I make it a pointer. So there's two ways you can declare it. You can say int star like that, or Tashiwa star, right? Like that.
Yeah.
Or you can say let me see, what should I call, let me call it A. Let me call it num, right? So you can declare it this way, which is fine, or you can put the star next to the variable. It's still the same. Regardless, doesn't matter how you declare it.
Okay.
So me, I usually do this so that I remember that these two things, there's a pointer. So without the star, it's just the address. When I use the star, it means, remember, the star is called a pointer. So if I use both of them in combination, right, like the star and the variable, I'm pointing to that
The
address.
address of the
Yeah,
variable.
yeah. So in a way, it's like this pointer saying, is doing this, like go to which address, this address, or X, whatever. So go to that address and get that value. So the variable
Okay.
in this case, the moment there's the star, the variable no longer stores a value, it stores the address. If you want to access the value, you point to or go to the address. So let me show you. So I'm going to output an address. I'm going to type in label address here. Okay, it's going to crash, but then let me just type this code. I'll fix it right now because it's going to crash. Why is it going to crash? Because this address is this variable currently has nothing in it.
Mm.
So it has no address.
It has to be assigned
It has to be
to
assigned.
something.
Yeah, let me
Okay.
show you when I run. It should crash or it should not output anything. But then C++, you never know. Okay, it happened to output something.
But
Yeah,
not an
but then,
address, clearly.
but okay, let me show you now what that is going to fail. Let's point or go to that address, right? So I'm going to output these two things in combination, meaning that I want the value at that address stored inside num. So now you shouldn't get anything, but then you never know. Yeah, you see now it crashes. It just stops there. Yeah, that's what I said. You cannot use it without initializing it.
Okay.
So
I
the
just
way,
want to ask,
yeah.
when you put a star in front of something you declared as a pointer, it's going to give you the value of the pointer.
Yeah, so let me make the diagram here. So let's say this is num, right?
Yes.
Yeah, so this is num, right? It's remember, we're not worried about this address. This is where the pointer itself resides, this whole thing. Remember, everything you declare resides at an address.
Yes.
That address on the left-hand side, it's where it resides, the pointer itself, the thing that we've declared. But then the actual content of num is an address. So let me show you. So let's say we want to store the address of this one, right? Let's say this is A. No, I call it A, yeah. I want to call it A. I'll show you right now, declare in my code the variable named A. So what I want to do, I want the num, this address or this variable without the pointer. Remember, without the pointer, it stores the address. I want it to have the address of this one where the variable currently resides, which is going to be OX 41s and then F, right? So now the pointer now stores addresses only. You see, I'm putting in an address, not a value. So what
Okay,
happens?
so num is
So
the pointer, right?
technically, what's happening right now, I'm telling this num. So when I use the star, right, this is what happens when I use the star. I'm saying to point at that address when I use the star. That's what it means. So let me delete it. Let me start from here so that it goes around like this. And then there we go. Yeah. So when I say point, right, what happens is I'm saying point or go to this address, which is this one, point to, that means it's going to go to that address and then check what's inside that address. It's that value. So let's say here, since we're dealing with an integer, I'll say 10. And then I'll obviously need to change this from data int. Now it accepts integers. And then this one, data, it accepts, let's just say it accepts an address, right? I don't know how to phrase this, but it's like it accepts an address of integers, right? It only accepts
Okay.
addresses. So just keep that in mind, right? So what happens is if I point to this num, it's going to go to that address. I'm saying point or go to that address, take whatever's inside the box at that address, which is the box A, and it has the value 10. Then it's going to display 10. So let me show you how I write that in code. So
Okay.
I'm going to say A, right? Initialize it to 10, right?
Yes.
And then I'm going to say num. Remember without the pointer, it's just the variable itself. Basically, it's just it stores an address. Don't try to store numbers. Store an address. So how do I store the address? Remember the address of operator we're using. We need that to initialize the or to change the pointer. So it's going to take an address of what? Of A. So that's what it's going to take. And then now, let me output this 2 lines. Let me output this. Let me say address of A. I will also need to output the address of A so that you see that they're of the same value. And remember, if you use the pointer without the pointer without the star, then it outputs the address because the variable itself stores an address.
An address only.
Yeah, so the pointer there is to help us. So basically, it's like the pointer is two things. It has this value, and you can use the address of without having to say address of. You see here, I had to say address of. Here, I just use the name, which
You
is
just
technically
use the
saying address of.
name.
Yeah.
Okay.
So let me build and run. We should see the same values for both addresses. I should have said address of num,
Yeah, but it's all
but then
right.
it's fine. You see, they're exactly the same. It's this diagram that I was talking about. I initialize this variable, this pointer, to be the address
Of A.
of another variable, which is A. Here I'm just doing an example because remember what I said, we can't really know exactly in which address where the computer stores the things. It keeps it's random. So next time you run it, the address would have changed. It does it randomly.
Okay.
So yeah, that's why it's hard. That's why if you
Which is
remember
why it's called random access
random access
memory,
memory.
right?
Yeah,
Okay.
exactly. And you're starting to get it now. So all of these
Yeah.
contiguous blocks is right.
Yeah.
They represent what we call RAM, random access memory. So sometimes it stores it in the shelf, and the next time you press run, it shifts it and then moves it somewhere here. And then next time somewhere here. So we can't keep track. That's why we have to use things like pointers and address of to see what's the actual address now that I've run it after maybe 10 days, a few days. What's the address now? Because I wouldn't even be able to keep track. I'm not the computer. I don't have the brain of a computer.
Yeah.
Yeah, so now so far I said display the contents of num, which is the address, right?
Yes.
That's num without the pointer.
The
Now, when I
star.
use num with pointer, I'm saying the star is saying point to or go to. So it's literally walking and walking. It's like going to a friend's house. Go to my friend's house. Imagine you store you store the address, right? Basically on a piece of paper. When you have to go there, you can say technically you are pointing to that address. So you've stored it, you've written the address on paper or in your notes app on the phone, and then now you're pointing to or going to that address. Now you travel. This is you walking. You're walking, and then you get there, you're like, hello, Chomi, how are you? And then you catch up and things like that. So that's the let's now get the value.
The
And
value.
you see that the value is the same.
It should be 10.
Okay, let me not say address of, because if I say address of, right, it's like I'm saying this one. Remember, the address of where the pointer is actually residing is not the same as the value that it has, which is the address that it has. So
Yeah.
so I don't think I should phrase it as address of num. That's not the address of num. That's the value of num. So let me say value of num. So when I want to say value of the pointer, I'll just put a star there like this
Okay.
to distinguish the two. So
Okay.
we now have this. So now let's output the value of num, right? Whatever is inside the box. So value of pointer num. When I point to that address, what do I get? So point to num, right? So point to num. I'm expecting 10 because what's it?
10.
Well, whatever num is pointing to, that address inside A has the value 10. So I am expecting 10. And you see something funny about pointers. If I change, I don't need to change A, but I can effectively change its value. That's the powerful thing about it. You see, there's 10. Because I went to that address or that location, and obviously I expect to find what's at that address, which is 10.
Exactly.
Yeah. So this is the tricky thing about addresses, right? That's why we use addresses when we want to change the values of an array. We pass it by address, or the object, we pass it by address. You'll understand why we need to pass it by address.
Okay.
When you pass it by address, right, in essence, you guys are in sync, you're linked. What does that mean? It means that, let's say Chomi is not at a place, you have her address, most. You can go to address and burn a house. So you can make permanent changes to where she resides because you have the address.
The address.
Yeah. Or you can go there, not even just not to burn. That's too extreme. Yeah, but it
Maybe
happens.
paint the
Yeah,
house.
it happens. Maybe Chomi stole your man from you. You're angry. You go there, I'm burning this house because you have the address. That can happen. Or they just say you just wanted something to drink and you're like, ain't no way
Yeah.
I'm buying this thing.
I'm
Maybe,
gonna go to Chomi's
yeah,
address.
maybe she stays in the next block, right? So
Yeah.
I'm just gonna walk to Chomi's house and I know the address and I know where she keeps her keys. She hides her keys under the mat outside. Yeah, so I'm there on site. I'm there. Take out the keys. I unlock. I go inside the fridge. I make myself at home, and I know Chomi won't mind. I'll
Exactly.
explain to Chomi, I was at your house.
Don't
Yeah,
worry, Chomi.
yeah. So it's like that. So now let me show you. Now I can point to that address, right? Basically, I'm going to that address. So it's like I'm literally walking and I'm going there to that address, and then I'm changing whatever thing is there, or I'm opening a fridge, whatever you want to do. So let's change this to 1,000, right? Let's change that to 1,000. So after changing that to 1,000, let me not point to it anymore. Let me use A now to show you that whatever changes I've made, since I have
I'm
access to
gonna
it,
apply to
I'm gonna
A.
apply to Chomi. So now Chomi is going to a fridge and saying, okay, well, what is inside the fridge? Okay, let me make it this. Let me make it a trace. Let me say 1,000 right there. And then let's say now you went in there and you took what from there. So obviously there's few things in the fridge. So let's say now the amount of things in the fridge is 850, right? So now show me is like, what do I have? What's the value of A now? What is inside of my fridge? So obviously it's a variable. I'm just going to output A to get the value. I want the value, not the address. I just want the value, what the thing that's inside A. So let's see. You see, if something funny will happen. For some weird reason, Chomi has been affected, but then I'm the culprit. But then the
But
other one
Chomi
has
is
been
affected.
affected because I have her address. That's why. So whatever changes I make, they'll also affect Chomi. So that's the whole point of passing it by address. When you pass it by address, just know that you can everything that every change that you make, it will affect the value inside that box. As long as you point to that address, make sure you point to that address. It's a different story when I change the address, that's a different story. I'm no longer linked to A. Yeah, so for example, I have int B, right? I say is equals to 95. It becomes a different story. If I do this, I say num is equals to address of B, right? If I point, if I output point to num, right? And then obviously I'm expecting to get 95 because now address has been updated. Now I'm pointing at a different shelf or a different address. So now the value that should be displayed is 95 because that's
95.
That's what resides
That's the
at
address it's pointing to now.
Yeah, there's 95.
So you don't have to like deallocate anything with pointers. You just simply point to something different and it can work normally from there.
Yeah, you don't remember pointers, they're just storing an address. And what happens is this is what it's called, it's sitting at what is called a stack. A stack, you can think of it as like it's like obviously it's a bit different when you go to your granny's place, right?
Yeah.
Especially if your grandparents they don't have their own kids, right? Obviously, their own kids have you now. You are their grandchild. Yeah. So obviously, if you notice something, grandkids they are very kind-hearted. When you go to their place, they'll make you sit on the couch and treat you like a king or a queen.
Exactly.
So they'll spoil you. Everything will be done for you. You can imagine that's the stack. The stack is your grandparents. Everything is managed for you. The memory, the deleting and allocating. Since how do I know that I'm using the stack? Because there is no use of the keyword new and the keyword delete. So I'm not using I'm using the stack because did I use new here?
No way.
I didn't use new. So therefore I'm using the stack, which is I'm at my grandparents' place. If everything is being done for me, all I do is just sit on the couch and be their grandchild and be cute. They cook for me. They might even
do everything for you.
They might even say, are your legs so let me massage your legs. I've seen it, but then I've seen it with kids when their children bring their own children, right? So when they bring their grandkids, I think it was a grandson, right? He was, how old was he? He was still young. I think it was like 6, 7. That guy was literally getting like princess treatment. He was sitting there. You would even ask for the remote, and then they'll give him. I'm like, grandparents are somehow most. Hey, he was literally chilling like a person who pays the bills of the house. He was chilled. I'm like, it must be nice,
yeah.
Yeah, so that's why I say grandparents. That's the stake. So yeah, so now we need to expand this diagram a bit so that I show you what the stack is. So you can imagine everything that's here is on the stack. So it's like this. So this is what we're going to call the stack. Yeah, this is prince or princess treatment. Your grandparents doing everything for you. They're like, guy, your parents are abusing you. Come here.
It's fine.
Let me take care of you.
Yeah, no.
You see what I was talking about?
It did that thing I saw.
Yeah, I don't have the time for that. But then just know this. I'm just gonna label it at the top there.
Okay.
Obviously, I need to increase the text size so that it's very visible. Yeah, this is your grannies
the
here.
stack. The only thing I know about the stack is LIFO or is it FIFO? I don't know if you know that last in, first out thing.
Yeah, I know. A stack, right?
Yeah, first in, first
A stack,
out.
right?
I don't really know what is the stack.
A stack, right? Let me show you a stack of, let me say plates, right? So this is what we call a stack. The question that I want you to ask yourself, right, is how would you get the bottom plate? would you lift the whole set up and then take the bottom plate? Or how would you go about it? Or what's the
I'd
approach?
take the first plate on top.
But then the first place, if it now that's a correct answer. Now the first
Mm.
plate, the plate on the top, is it the first plate that was placed, or this
No, it
is the
was the
last one?
last plate that
But
was
then it's the
placed.
first one to
It's
be
the first
removed.
out.
Yeah, so last
Yes.
in, first out,
First
LIFO.
out.
So this
Oh, is the
the last
stack.
one to be added, the last one in is the first one to come off to
Okay.
be removed. So that's LIFO or LIFO. That's a stack.
Okay.
You only remove
Okay.
from the top. Basically, you remove from the top and you remove the latest one because you
Okay.
cannot imagine there's 16,000 plates that are stacked up.
Oh,
You can't lift all of them. It
okay.
makes
I
no sense.
understand now. That's how the memory of pointers works. It works as a stack.
No, no, that don't mix the two. It's a
Mm,
the stack is like a design approach. It's sort of like OOP or
mm,
structs. It's a way of structuring your problem. Let me explain queues now so that you can
mm,
understand why we need why stacks is a sort of way of solving a problem. So
mm,
a queue of people. So stack it uses what we call first in, first out, right?
mm,
So with these people here, let's assume this one is the with the green shirt is the first one. Would
mm.
they would let's say you're at Pick n Pay, would they say next and then the last one goes? Will that be fair? Hey, they will
No,
fight you.
the first
Everyone in the queue
one.
will fight you. Who do you think you are? I came
Yeah,
first. So the first one to come is the first one to come to go off the queue. So first
yeah,
in, first out.
yes.
So so the queue mimics the queue in real life. Like I said, computers are meant to mimic the Earth, what we do on Earth. But
Yeah.
at the end of at the end of the day, they're made by people who live on Earth, programmers, just people
Mm,
like you and me. So obviously they're
yeah,
gonna borrow from that. The same thing about stacks of plates. They borrowed from the stack of plates. It's a way of
yeah.
designing or solving a problem. Functions,
Mm.
if you didn't know, functions are actually stored inside the compiler uses a stack to store function.
To store functions.
Yeah. So that remember why do we need to use stacks? Because inside here you can call maybe a function called sum that takes in x and y, right? So
Yes.
obviously what's going to happen is you're gonna have this. Let me show you. You're gonna have this, right? You're gonna start here. You're gonna have your main function here, right? Which is the main function. That's the one that you're gonna have, right? You're gonna have the main function. Then
Mm.
now within the main function, you are calling, so therefore the latest one to be called is going to be at the top. So it's a stack. And then the latest function that you've called is sum, right?
Yeah.
And then it's going to evaluate the sum function, calculate, and then since here we have okay, here would be a void, but then if you wanted to return something, let's say ans is equals to. So that function returns something. It's going to calculate and
Mm.
return something. So it's going to calculate, sum is going to calculate, and then once it's done, push a value inside a variable that's sitting inside the main function. And then once it's done, it's going to sever those ties, delete from the stack at the top. Remember, we delete at the top. That's a stack.
Mm.
So it's going to delete, remove the plate at the top. We have returned the value already, so now I can cut the
Oh, so
connection.
that you can even call the function and use it again if you
Yeah, so that you
want.
can use it again. So it needs to be deleted. So now I'm back.
Mm.
After it goes line by line, remember. After this line is executed, the function is no longer in memory, it's deleted. But automatically, like remember what I said, the stack is your grandparents. Everything's managed for you.
Mm.
And then I press
Mm.
enter. I press, and then whatever line of code came after, let's say the line of code was ans. So now it's gonna execute this. And then when it reaches this return 0, it means everything was fine. So now it also deletes the main function too, because there's no use for it. So you see, it makes use of
Mm.
what we call a stack, right?
Yeah, I think I understand now. Everything is managed. You don't have to keep on
Yeah.
deallocating. It does that itself.
Yeah. So
The
maybe,
compiler does
so
that.
let me make it this example, let me extend this example step further so that we can actually have a literal stack. So let's say with the sum function, let's say it also called a function that evaluates x and y. It's called validate X and Y. So when I'm now within the, okay, let's just say validate. Now when I'm now within the sum function, I also call validate. You see, it stacks up. It becomes it goes at the top
And
of
the
the stack.
moment you leave some, then
And then the moment I
validate
leave
gets
validate,
deleted.
yeah, so I need to start with validate, obviously,
Okay.
because just imagine this looks like a stack of plates. So obviously I remove from the top. So the
Hmm.
latest function, which is validate, which makes sense because validate is within sum and then sum is within main
The
function. So
main
it makes
function.
sense to work that way. So at the
Yeah.
top here, it's going to delete, it's going to validate X and Y. When it's done, obviously it's going to, okay, let's say it's just a void function. It just validates. So obviously there's nothing to be returned to sum. We're just validating.
Yeah.
And then if things didn't go well, let's say there's an exit code, let's say exit. So obviously if it didn't exit, then everything went fine. Then it's going to remove validate out of memories. We can reuse it later on if we want to. Then now it
Mm.
goes inside sum. Since we've validated X and Y, it finds the sum, it returns it into a variable called answer inside your main
The main
function. So
function.
basically it calculates the sum between the two. Let's say the sum here that you wanted was 10 plus 20. And then it returns the sum. By return, what do I mean? It means this function will be replaced by the actual sum, which is 30, which is the same as just
Mm.
declaring it like that. But
Mm.
then we create a function so that we keep changing the values of X and Y. Or we can
Mm.
keep calling the sum function again, because the main thing that
Over and over. Yeah.
we don't want repetition. If you see repetition, replace that code that you're repeating, place it into
With the
in a function,
function.
and then call the function multiple times. It's better that way. You have less few lines of code. So after
Okay.
executing sum, it's going to delete the function from the top of the stack and then cut that connection. And then we have already stored the value. Execute the code inside from after execute from that line where we call the function, continue downwards. And then it says return zero. Because return zero tells the operating system that everything went well. I'm done with my function. Then it deletes main function. So
Okay.
that's it's a design philosophy. It's a way of solving a problem. So
Okay.
they use text to to solve function problems, right? If they had
Mm.
used
A
if they had
queue.
used Q, it would have been messed up because think about it. It would have been like this, and now things won't be executed in the right order. It's gonna crash. Your
Mm.
code is gonna crash because in order for me to execute main function, I would have to execute some function and get the answer. So now this line
Mm.
would crash. It will stop at this line and say, "Hey, I don't know
Mm. What's
what the
answer?
value, what's the answer. I know that
Mm.
sum is a function, but then since you're using a queue, I don't know what the answer of sum is."
Okay.
Yeah, so
I get it.
that's it. That's why we need stacks and queues. You can use pointers to implement that. Remember what I said, pointers are a way to store addresses instead of the physical things, so that we save
Mm.
bytes, we save memory. So
Mm.
that's why we use stacks to well, that's why we use pointers to implement stacks and queues.
Okay.
Yeah, because we want to work with addresses, not the objects themselves, because that would consume a lot of memory.
Mm.
Does it make sense?
Yes, it does.
Okay. So since now we are done with pointers, that's the stack, right? So now,
Mhm.
what about you? You've been asking about what about new? I've seen stacks being pointers used with new. You can use them.
Yes.
So let me show you. You can say int, um, let me say x, right? I can say
Mm-hmm.
new int like this.
Mm-hmm.
So I'm saying create a new int, right? Basically allocate memory for a new int inside the heap. There's now this thing called a heap. There's a stack and a heap. The heap you manage yourself. It's like you're at your parents' house. They tell you why
Mm.
didn't you wash the dishes? Now you wish, I wish I was at granny's at my grandparents' place now. They're making me wash
Yeah.
dishes. I must be, they're making me be responsible. My grandparents wouldn't do that. That's when
Yeah.
you start fighting with your parents. They're like, oh, you wanna go stay there, don't come back. You know,
Eh.
parents. And then you start going, oh, you're
Exactly.
even considering going, come here. We're gonna beat you for thinking
We're
like
gonna
that.
hit you for that now.
Hey, the parents matter. So yeah, we have the heap,
Mm,
right? Inside the
yeah.
heap. So inside the heap, you see this new keyword, right? It's like I'm telling you to allocate inside the heap separate memory space, right?
Mm,
It's still inside the RAM, right? But it's like a separate reserved memory space, right? Or an area whereby people are supposed to be responsible. You manage everything. That's why.
mm.
So every time you see a new keyword, there must be
They
a
must be
delete.
delete.
Yeah, they
Okay.
go hand in hand because you are managing. Here, yes, they're telling you to allocate enough memory for an integer, which is going to be 4 bytes,
Mm.
right? Which is just 32 bits. If you remember what we were talking about
Yes, yes,
last
yes.
time, yeah. So what happened? What really happens, right? The variable is called x, right? The pointer. But then it's
Mm.
remember the variables are always stored in the stack. So now you're gonna ask
Mm-hmm.
yourself, then how will this thing look? This is how it's going to look. Copy, paste there. It's inside the stack, and then let me change this one, right? Let's make x this one. So this would be x. It's still an integer, but then it's no longer just an int. It's a pointer. Okay. Let me just write it as int pointer like this. That's the data
Mm-hmm.
type. So now you're gonna ask yourself, okay, now how do I know what's the value now? Well, remember we said it's allocated on the heap. So now there's an arrow from here to the heap. So now I'm gonna explain. Yeah, I feel like diagrams they really do help explain these things because now you'll
Mm.
understand why we need to about null pointer, about delete, all those things.
Yes.
You're
Why we
gonna
need those.
understand. And I said
Okay.
a new int, right? So this box stores integers. So I said new int. So data is going to be
Int.
int. You definitely understand this. You'll be shocked how easy it is once you see once you
Mm.
see this thing. So this is a new int, right? We can just say let me put it this way. This is an anonymous, right? We didn't declare
Mm.
a name. Think about it.
You just said new int, yeah.
Yeah. We just said we want an int. I didn't say we want an int named
Mm.
because we have that pointer. It points to that address of where this
Of
point.
whatever.
And remember,
Yeah.
it still also has an address of its own.
Mm.
That's the thing. It still has an address of its own. So I'm going to put it from the on the right hand side, right? It's still
Mm.
because everything is an address. So don't forget that. So
Mm.
now we pointed to the heap. I've allocated.
Mm-hmm.
That's what new does. It's basically saying allocate separately in a in a memory man in a how do I put it, in a managed environment, which is going to be managed programmer managed
Then
space, right?
yeah,
It's
space, yeah.
managed by the programmer, the space. So there's the new, right? Now you're gonna ask
Mm.
yourself what value goes into int.
Mm-hmm.
It depends with the operating with your compiler. So let me point to X and see what do we have. It might initialize it or it might not. We do not sure. Let's see.
Mm.
It might be equal to 0 or some random value. So let's just test it out and see. Yeah, you see,
A
it's
random value.
it's 1 mil. Is it 16 million? Yeah, 16,784,000. So that's why it's important to initialize values, right? Let me see. I think
Mm.
this is possible. Let me see. I think you can do this. Let me just test it out. Let me build, if I remember correctly. Yeah. Why am I using round brackets, right?
Mm.
Let me show you 3 different ways of initializing variables. You can say int y is equals to 0. That's the first approach.
Mm-hmm.
Or you can say int y and then you put curly braces. They're all this. It's all the same thing. I'm initializing.
Mm.
Or I can say round brackets. I'm still
Same thing.
initializing y to 0. All these three
Okay.
ways of initializing are the same. So that's why here is this is that's the I can also do curly braces here.
Mm.
But then the only one that
Input
I
zero.
can't do is the equals. It wouldn't make any sense here.
Because there's already an equal sign.
Yeah, there's already an equal sign. So that's why
Okay.
I say there's many ways.
All
So
right.
let me just add the comment here. So this is what is called a constructor initialization, right? Initialization. And then the equal sign is in the textbook is called the C style.
Assignment, ne?
The C style
Assignment.
initialization, or all of them are assignments. I'm giving you the right terminology for each. Yeah, so
Mm.
it's called C style because that's how it was implemented in C language, which is
Okay.
the parent of C++. And then this one is called the list initializer
When you have
approach.
a,
List.
yeah, okay.
If you remember arrays, isn't this how we initialize arrays?
Exactly.
Yeah.
When you've got
So
a,
it
yeah.
borrowed from that concept of initializing arrays. But
Okay.
then when it comes to allocating on the stack, you can only use these two, the round brackets and the curly braces, because you already have the equal sign, right? So you see
Mm.
there's 0 there. Or if you feel like this is a bit cryptic for you, it's confusing. I don't know why you think it's confusing because it's not that confusing. You
Mm.
can point to that address, right? Remember, point to it means it's going to travel via this thing, point and go here inside the box.
And
So
get the value
what do I want to do with that? What's inside the box? I want to change the insides of the box to 0.
to
So
0.
you can set it on a separate line using the equal sign. There's many
Okay.
ways you can do that. There's 3 ways. Literally. So this is the third approach. All of them would initialize it to 0. So there we
Okay.
go. You see the 0 there.
All right.
So far, do you understand?
Yes, I do.
Yeah. So we can still work with the pointer the same way we've been working with it. So there's nothing new that I need to introduce here. So now what I need to introduce is how to deallocate, right? So how to delete, right? Since it's only one int here,
Yeah.
and I don't need to say delete and then square bracket.
A
Square
phone.
bracket is for a
Okay.
collection.
Okay.
Yeah, it's for a collection. All I have to do is just say delete X, right? It deletes.
Okay.
So what does delete do? Remember here we allocated 4 bytes.
Mm-hmm.
What delete does, it says subtract 4 bytes, delete those 4 bytes. Here it
Okay.
was saying plus 4 bytes, add 4 bytes of memory and reserve that for storing any integer.
Yeah.
Yeah. And then here I'm saying undo that process,
Delete.
delete the space.
Yeah.
Yeah. So delete
Okay.
that space. But then what happens when you actually say delete? Let me show you what happens. Remember, you said delete the memory. Basically, it's going to delete all of these things
Mm.
like this, right? All of them. Okay, the address still the same because that's the first address. But then, don't you see something that's still a bit problematic? You still have the connection.
Mm.
I'm still pointing.
Mm.
So what I need to do is after deleting always, I need to say x is equals to null pointer. What does
Pointer.
that mean? It means point to nothing. So basically it means,
Mm.
but then the actual implementation inside C and C++, null pointer is
Mm.
actually it points to a value 0, the integer number 0. Or you can
Yeah.
or it's actually represented like this. You see, like this. Which the computer knows that, oh, when it sees that, it means I'm pointing to nothing. So now, so that you don't mistakenly access something that's empty. There's no memory, there's nothing allocated anymore. So when you
Mm.
access this now, it's going to give you a clear error. That's the main point of doing this. It will tell you,
Mm.
you are pointing, it's pointing to nothing. What it's pointing
Mm.
to null pointer. What are you trying to do? If you do this
Mm.
one, right, it's just gonna crash. It depends on the compiler also. But the most of the time
Mm.
it will just crash and not give you a clear error. So
Okay.
that's why we need to sever that connection and connect it or point it to an empty or 0, an empty location. So that if you try to do this, do you know why we're doing null point? So that
Yeah.
after that thing has been deleted, if someone tries to say point to,
To,
yeah,
yeah, that
it's going to
address.
tell you,
Yeah.
wait, you are pointing to 0 or null point. What are you trying to do?
Exactly.
So let's see what error. Hopefully it says you're pointing to null pointer now. Okay, it does. You see, that's what I said. It depends with the compiler. You see, with code blocks, it just shouts at you. But
Mm,
then,
mm.
but then if you use things like this thing called Code Light, this IDE called Code Light, that one it tells you exactly. So let me do this also. Let me delete that and see what if it should normalize giving us errors though. This thing, I guess the compiler that they're using is not that powerful.
Mm.
So let me do this. Let's run it via. Yeah, you see now it gives you a random value because there's nothing in that memory. But and you end
Yeah, for it to
so
get, yeah.
so the problem is you end up having the ability to access that memory when you shouldn't be able to access it because there shouldn't be anything since you use the
Mm,
delete keyword there.
mm, mm.
So let me see. Let me do this. Let me copy this. Let's create. Let's do this thing. Let's do this thing inside. Let me see. Let me compile it via the terminal. This terminal has the latest compiler, right? I think this
Mm.
one should help. Okay. Okay, there's nothing here. So let me say cd C drive, right? Users, and then I think it's data. Yeah. And then now I have all of these folders, right? So let me
Mm.
move inside documents, right? So I'm gonna store it inside documents, and then okay, I have quite a lot of documents here that I know. Yeah. So now I'm going to create. You see the power of coding. I'm gonna do everything via the terminal, but then you should check inside. You see inside of my folder. Do you see any main dot or CPP file here?
Mm-mm.
Let me create it via the terminal. So I say touch, if I still remember, yeah, it's touch. Touch means create a file and then followed
Mm.
by the name of the file you want to create, main.cpp. And then now if I go back here and okay, yeah. Do you see
There
it?
it is.
And look at the time. It's the
How?
yeah, because I've learned a bit about the terminal online. So now I'm
Mm.
gonna copy the code inside of our main.cpp, Control S to save, and then close, right? And then now it's 1 kilobytes. So it is something, right? Now I'm going to
Mm.
use G++ to compile it. So main.cpp and then minus O, it means the object code should be sent to a specific file, which is the machine language code, right? So
Mm.
what minus O just tells the computer, okay, name it this way. I don't want you to give me a default name. Why am I doing that approach?
Mm.
Because it usually names it a.out or something, which is something we don't want. So let me show you.
Mm.
So I'm gonna press enter. It's compiling. Oh, it's gonna fail. We just wanted to test here. Remember, we just wanted. Oh, it didn't fail.
Mm.
Hey, this thing. You see, that's the problem with C++. It might not fail. So you see, there's the A, or since it's Windows, it ends with .exe. So yeah, so that's why
Okay.
we give it our own name so that it's easier to remember.
To remember, yeah.
To execute, you say dot forward slash followed by the name of the executable, which is a.exe like this.
Mm.
And then there's the code. Yeah, this is the error that I want. You see, when it says
Mm.
segmentation fault, it
Mm.
means that you are pointing to a memory that has already been deleted.
Deleted.
Yeah,
Oh.
that's
Mm.
why I was using the compiler. And you see why it worked because I commented out, I put back the null pointer so that it helps me figure that out. Now, when I see segmentation for it, I know, oh, I'm pointing to a null pointer. Why am I doing that?
Mm.
Then I look
Mm.
in my
Mm.
code. You see, that's
To
the whole
see.
point of the null pointer. If you don't
All
put it, it
right.
might just crash and give you a weird error. So let's do that. Let's check it out. Let's comment that line out for null pointer and then just rerun redo everything that we did and see
Mm-hmm.
that we might get a different error that actually makes no sense. So on my keyboard, I'm going to press the up arrow to view the previous things that I've typed. I don't want to
Mm-hmm.
keep typing the same thing. So obviously compile and then execute. You might see, hopefully we see the same error. Yeah, you see, it becomes a
Yeah,
problem.
a random number
Yeah, a
now.
random value. You think, "Ah, I'm safe, I'm safe." Yeah. If I
Mm.
tell you how much billions and millions companies lost from pointers, you'll be
Mm.
shocked. Pointers, that's why they made other languages like Python and things like that, because companies were losing millions from this. People forgetting to set
Mm.
it to now pointer because they simply fail to understand that there's still that connection. Even if you use the delete keyword, there's still that connection. You have to
Connection
set it
between
to
the
null pointer.
pointer.
Yeah.
Mm.
So
Mm.
hopefully you now understand pointers.
Yes, yes, yes,
Yeah.
definitely.
So what I'm going to do is, I'm sure they said Control Shift. Yeah. So Control Shift C to comment that whole thing that I've selected. So we have this, right? So let me make another example right of a point. So now we want to get the address of where, remember what I said, when you declare something, it's always stored at a specific address. I want to
Mm-hmm.
get where at the address of where the pointer is currently sitting at. Because like I said in the diagram, right? If you see here, the pointer stores an address, right, is inside its
Mm-hmm.
box, but
It has an address
it also
itself.
resides at its own the box
Mm.
that's storing the addresses. It's also at a specific address. The box
Mm.
that box. Remember, each box is stored in a specific address. So just
Yes.
because I'm using a pointer and I'm storing addresses doesn't mean that it also stops having an address. I'm storing addresses of other locations or of other variables or other boxes. So that shouldn't change my code, right? So this is I just set it to 200. And then you can also initialize it within the same time you're declaring it, but make sure
Mm.
the address you're getting, the variable has been declared previously on the top of
Yeah.
the pointer, or else it won't.
Okay.
Remember, it reads from top to bottom.
Mm.
Yeah, so that's why I'm declaring it at the top. So initialize that to address of A. So let's output the same way that we've been. So that's why I said I shouldn't call it address. I should say value of num, right? Which is the address that it stores, which is the address of A. So value of
Mm.
num, it's going to store the address of A. Now let me get the address of the pointer itself. How do I do that?
Mm.
So address of where num resides. So how do I do that? I would have to actually point to the address that it's point. Should I say? Should I point to? I don't think I should point to that. That won't work. So I think I should just say num like this, and then address of. I'm not sure if
Mm.
that's going to work, but it should work. If not, then we're gonna try the second technique.
Okay.
So let me see. But then it wouldn't make it. I don't think this makes sense. Address of and doesn't make any sense. Address of an address. But then I think I'm assuming this is the right address. You see, it's a different
Mm.
value.
Mm.
Yeah, so this is the address of where the num variable itself was declared. And then this is the
So,
value, the address that it has, the box itself, inside the box, it has another address, which is that address. And then here
of A.
it's where the box that holds that address
Yeah.
resides. Do you get the differences?
Yes, I do. I've
Yeah.
just seen this thing where they use the star and the ampersand sign together.
Yeah,
What does that
that's what
do?
they're trying to do. That's why I was thinking, should I point? But then I was like, would it make any sense? But then they do this, right? You
Mm.
point, so basically you point to that value, right?
Mm.
Remember why we have to point, right? But then I don't think that's gonna work. But maybe I think it works better with functions when you pass it as parameters. Here it's going to work
Yes, that's
different.
where I've seen it.
Yeah, it's going to work differently here. But then let's see. Yeah, you see, like I said, it's going to work different because when
Mm.
you point here, I'm pointing to that address, which is that other one, and then I'm saying get that address of where I'm pointing to. I mean, duh, you're really pointing there. So that's why
Yeah.
I don't think it's applicable here. You have to
Okay.
remove it there and say, what's the address of this variable itself, of where the box that's holding that address? What is its address? basically I'm looking for this value here, this one, where this box is sitting. I don't want what's inside the box. So if you do use them in combination like ampersand and star, what you're doing is you're saying point to that address, meaning go to that address, which is this, then get the address of that address. I mean, what do you mean? You're already at that address. So that's why the value was the same. That's why the value
The
was the same.
same.
But when you're working with functions, it becomes different. That's how you actually get the address of that thing where it's currently at.
Yeah.
Yeah.
Okay.
So that we are done with pointers now. Do you have any questions? Hello, do you have any question?
Hello. No. Hello. Can you please say that again?
I'm saying we're done with pointers. Do you have any questions about pointers?
No, I don't think I have any questions. Only when we get maybe to using it as in functions perhaps. But for now, I'm still good.
Okay. So we have that figure done, right? So now let me see. Ish. The thing is, to draw the diagram for arrays, it's going to be a bit demanding, but then let's see. Okay, so let me do this first, right? Okay, but then you definitely still remember.
Mm-hmm.
Yeah, because I want to save it. I want to save them as different diagrams. So we're talking about pointers. Then this one we had stack and heap, right? So that when I send you the images, you can distinguish between the two, right? So now I
Okay.
don't need the heap anymore. Yeah, my hips don't lie. Dun, 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 dun. So we have let me see. Okay, I want to explain arrays, yeah. I lost my train of thought there. So let me do this. Okay, it's still all addresses, right?
Mm-hmm.
Just remember that all of them are still addresses. It's still the same logic, right? Still the same thing. So the way arrays work, right? When you declare an array, when you say this int values, right? Let's create something simple. Let's say 3 values. You should store 3 values. So what happens is let me show you something. It uses pointer arithmetic. If you check in the slides, there is something called pointer arithmetic. So let me just try outputting values, right? I'm sure you've never seen this before, but then it's possible. You output the name of the array without indexing. It should give you an address. Hopefully it's going to give me exactly, yeah. It's going to give me an
Oh,
address.
okay.
Yeah. So what is that address for? Address, the way arrays work, right, is that the name of the array, it stores the address of the starting value, where the starting value is, right? So let's
Yeah.
say it starts here and I want 3 values. So it's 1, 2, 3. So these 3 blocks will be used contiguously, right? So
Yes.
how does it know when to move to the next block? It depends on the bytes, the size of
Yes, I remember that. The
yeah,
type.
yeah. So basically
Mm.
it's literally doing this. Let me show you. It's literally saying it's looking at the addresses and then adding 4 to it. Let's say it starts at 0x0, right? And then
Mm.
here it would now be plus 4 bytes to move to the next value. So this would be
Mm.
at 0x4, which is the fourth address. So let's view it in that way. And then this would be, what is 4 plus 4 is 8. So this would be
Mm.
OX8. So that's how
Mm.
it works. So that's why the name of the variable, the name of the array, it is the starting address. And so it keeps adding 4 to that address, and then it moves to the next available block, adds 4 again, moves to
Mm.
the next available block. So that if you pay attention to the addresses, you actually convert them to what is this, to what is this? What do I want to say? To actual integers, right? To actual numbers that we can read. You'll see that the numbers increase by 4, or the numbers of the addresses.
Increase by 4.
Yeah, because the data type, I'm storing 3 integers. So each integer is 4 bytes. So basically, I'm storing basically 3 times 4 bytes, which is just 12 bytes of memory. So how does it know? Because int is 4 bytes, and then there's 3, the number of integers that I need. So that's why the name of the I can even show you right now. Let me show you if you think I'm lying. I can show you. We can do this. Let me do this. Let me try it. Let me say plus plus. Okay, let me do this. This should be possible. This shouldn't. Okay, so it's demanding. It's fine. So I'm going to say values, and arrays are always 0 index. You start counting from 0 basically. So let's say this is 20, and then index 1, this is 30, and then index 2, this is 90, right? So we
Yes.
have these values, right? So you might wonder how it's calculating, how does it know? It's using basically pointer arithmetic, which is addresses, and adding 4 bytes to move to the next block or to the next address, right? So we could get the addresses of each. So let's do that. So the address of the first element, I can just output the name of the array on its own. That will give me the first address. Remember, the name of the array stores the address of the first element, which is this one. So I can just leave it like this, or I can just index and then say address of. I can
Address
do that.
of.
Either way is fine. And then address of values at index 1. And then see out address of values at index 2. So we're just storing a collection of values, right? There's nothing fancy about it. We're just storing a collection of values. So let's output and wait. So I want to try something. Yeah, hopefully I find a proper, but then you can see, let me show you. Is look at the rightmost digit. This is 4, right? And then all of a sudden it's now 8.
Yes.
Do you see?
So it means it increased by 4.
By 4. Because if you look at this one, they're still the same, all of this one. So the main thing we should look at is the rightmost digit. It was 4. How do we get to 8? We simply added 4. Why 4? Because each value in the array is of type int, which is 4 bytes.
Yeah, and so, 8 to C as well is also 4.
Yeah, it's also 4.
Hexadecimal, I think. Yeah.
Yeah, because what is 8 plus 4? That's 12.
Because it's 9, and then A, B, C, which is also 4.
Which is 12, right? Yeah, so which is also 4 bytes. So that's what I meant when I say it keeps on incrementing by 1. So it looks this is the diagram. That's why I was saying let's start at 0x 0 so that you know 0 it became a 4, it became a 8, and so on, depending on the number you've specified here inside here, how many values you wanted. So that's how it works under the hood, the memory. So just keep that in mind. So me, with my advanced knowledge, right, since I know that it works, it works in terms of bytes, right?
Yeah.
When I'm creating functions, right? Let me show you a trick, right? I can find how many elements are in the array, right? I can find how many elements are in the array by doing this. Let's try this. Let's say see out size of values, right? Right. So when I do this, right, remember what I said. When you're declaring it like this, right, it knows, oh, you want integers, but how many are those integers is 3.
3.
So how big is one int? It's 4 bytes. So therefore 3 times 4 is going to be 12 bytes.
12, exactly.
We're just doing arithmetic. You're just basically doing maths. So I should see 12. let's see.
What?
I'm the goat, man. I'm the goat. Yeah. So now how do I find this size here? This three. I can find the
Yeah.
size. I can find the length of any array. Let me show you. That
Mm.
again we know that size of, and you just pass the name of the function, the array only. It gives you
Mm-hmm.
the total bytes reserved.
Exactly.
Right. So now the question is, how do I get to 3? I just divide by 4, right? By the size of
Yes.
each element, right? How do I do
Exactly.
that? It's simple. I just say divided. I just do this. I say divided by the size of each element. How do I find each element? I can just use n. I can just say, let's get the
One,
first.
yeah.
Yeah, let's just get the
Of the
first
first
element.
one.
Why one of them, right?
Yeah.
Divided by one of them. So the size of values 1 is going to be 4 bytes. This is going to be 12. 12 divided by 4 is what? Is 3, which is this
Exactly.
number here. So
Which is what we're supposed to get.
I'll find how many elements are in the array using this bytes.
Mm.
This bytes. So the output should be 3 because I have 3 integers. So let's wait. There it is.
3.
Yeah.
Exactly.
And then if I increase this to 100, it's still gonna work.
Mm.
Let me show you. Obviously, okay, it's fine. Basically I didn't initialize the rest of the array. I only initialized the first 3. So I should see 100.
Mm.
That's how you find the number of elements in the
Exactly.
array. It's basically
Okay.
it's basically simple maths. So since I have 100, now things have changed. This is now going to be 100 integers. How many bytes is each int is 4 bytes. So now it's going to be
So
400,
400 bytes. Yeah.
400 bytes. And then now I say size of the whole array, which is 400 bytes, divided by the size of each element, the size of each, whatever the data type is, size of each, which is going to be 4 bytes. So 400,
Mm.
400 divided by 4, which gives me back the size of the array, which is 100. So in C, this is how they usually did it and things like that. And even in C++, this is the only way you do it. There's no other way. But then for lecturers, they don't want you to do advanced things. They avoid touching these things. They just say, yeah, make it a constant size of array and just say 100. Just whenever you need to change, just change here to 3 if you want to change. Just do it that way.
Yeah.
I want you to really understand what's going on. You can still do it that way, but you have a really powerful understanding of what's really going on.
Mm. Yeah.
Yeah, so we have that.
Okay.
So arrays, this is how it works. You just make sure you put the size there when you're declaring it. If you don't put the size, then we're gonna have an issue.
Okay.
Yeah. So arrays, we are sorted, right? Do you
Yes,
understand arrays?
yes, yes. The only thing about arrays, though,
Yeah.
or the types that I find a little bit challenging are dynamically allocated arrays.
Okay, let's do those.
Mm.
So, okay, now we need to put back the heap. So remember what it did. At least I showed you one of the approach. So let's say values, right? Same name. Remember what I
Mm.
did last time? I said allocate one int, right?
Mm-hmm.
Now I can say allocate multiple ints and put the square brackets, then say allocate 3 ints
Mm.
on the stack. I can do that. So now I've created a whole array. And remember that arithmetic that it starts there and then it adds 4 bytes every time. It still applies. It's still the
Yes.
same thing.
Oh,
The only
okay.
difference is that I'm managing the memory now. I'm
Mm.
no longer at my grandparents' place, which is the stack. I'm now in the heap. So now there's going to be that
Mm.
arrow. That arrow is going to point to the starting element, which is at index 0,
Mm.
which is basically this address, which is just values, right? It's going to point there. Remember, the name of the array is it points to the beginning of the array.
Mm.
The address of the first element, which is at index 0.
Yes.
Yeah.
Yes.
So the same thing still applies here. I can just say output values here. And then let me also show you that what I'm telling you about is right. I was supposed to also verify with the arrays, but then it's fine. So let me say
Mm.
address of values at index 0. This should be the same. With the level of understanding that I have, this should be the same.
It should be the same as which one? Line 38, the previous
Yeah, remember,
line.
remember the
Oh,
name exactly. Remember the name of the array. It
mm,
points it points to the address of the first
of the
element.
first element.
Yeah.
Okay.
And then
Okay.
it starts it increases by 4 every time to
To
move to the
get to
next.
the next
Yeah.
element.
Yeah.
Okay. I
So that's why
understand.
I was expecting these things to be the same, and of which they are the same. And remember,
Exactly.
with pointers, if you use it without the Watashi star,
Yes.
it's the address.
Address.
Yeah.
Yes.
Now when you point to, you're now pointing to that value. So now
Mm.
how would we point to the values, right?
Mm.
It's still the same thing. You'd say this value, this array, right? Let me see. Okay, it's still fine. Yeah, we'll just do this. Okay,
Okay.
yeah.
I just quickly need to use the loo. I'll be back in a second. I'll be back in a
Okay.
second. I won't leave the session. I'll be back now.
Okay.
Okay. Okay, I'm back.
Okay, welcome back. I come
And
back.
also, are we gonna do that thing again like yesterday where we end the session now before 10:30 and then we'll meet again later?
Do you have a
Can we do
class?
that? Yeah, can I just find out if we can do that as well today? Because yesterday I did that and I forgot I had made plans with the friend. The friend is here now and I'm like, Aibo. So I had to
Oh,
cancel. Sorry about that. So can we maybe try it again today?
okay, that's fine because there's a lot of information to unpack.
Exactly. So it also gives me a bit of time to absorb. But so far, I'm really, really understanding because this new int, ne, I was
Yeah,
very, very confused because it's the same thing we do when we're creating a 2D array, but in place of that value 3, it's int rows and then int calls again.
yeah,
So now I even understand now why exactly they were doing that because I was just doing it because I see it in the slides and in the tutorials, but I wasn't understanding exactly.
yeah.
You
So
see.
let me just quickly explain it so that this three, right? So
Mm.
remember, we're gonna have this thing, right? It's put okay. Let me remove that. Oh, it's why am I doing this? Why am I making my life difficult? There's the diagram here. So it points to the first element, right?
Yes.
Okay, let me do this. Let me structure it proper. So let me take this. Don't mind the address, right? Just know it's a different address. I don't have time to be renaming things here.
Yeah, okay. It's fine.
Yeah, so this we know that it resides at that address, right? So here the array that I remember the array will still the pointer still be stored inside the stack, but then it now points to the heap memory, which is it points to the address of the first element in that array.
Mm.
Yeah, so that's what's going to happen here. And then we're going to have also other, come on. We're also going to have other elements underneath it and stuff. You don't know
Yes.
how to continue because, I mean, it's going to add 4 each time, right? You don't have to
Yes.
worry about that. It knows.
Yes.
As long as you have, okay, here we're just representing 3 elements, right? So I just need only those 3.
Okay.
Yeah. So this, and then, yeah, you know that each one has its own address. So I'm just going to use 4.
Mm-hmm.
I'm just going to reuse those ones so that you can see that it does increment by 4 bytes. And it
Okay.
depends on the data type. Since I'm using int, it's going to be 4 bytes. If I was using short, it was going to be 2 bytes. So
Okay.
yeah, it depends. Like I said, it depends on the data type. And then everything is pretty much the same. Here, or remember, they don't have names. They just have
Mm-hmm.
addresses. It's just gonna be question marks. They don't have names. We didn't name them, right? Remember,
Mm-hmm.
so we don't have to worry about that. We're accessing it via addresses or via indexes. But then
Okay.
the index is going to do that arithmetic that we're talking about. It's going to
Yes.
calculate, and then it knows, oh, you want the third one. It's going to do the calculations, the maths for it. You don't have
Okay.
to stress about how does it calculate.
Okay.
Yeah,
So
so
to change or to set a value of something in a array, you can either use the pointer, right?
yeah,
Or you can use the index. So those are the two ways.
yeah, you can also use the pointer. So let me show you. The thing is, I'm not sure if I still remember the formula, but then
Mm,
let me think about it. But then you can still use the same calculations, right? So this
mm,
is how it's going to look in the heap, right? So I'm just going to rename this to heap
mm.
because my heaps don't lie. So I'm gonna leave it there, and then let me see. Akancha, what's another way of calculating this thing? Because you see this thing that we have here, they use that it's used to do the arithmetic, right?
Yes.
Yeah. So if I'm not mistaken, Akancha, what is it? Is it the index? Uh, is it the index plus the size of the, yeah, I think it's the index plus the size of something. Size, the address, I don't know which address. Is it the address of the array itself like this
Mm,
or like this? Is it the address of itself like this? Yeah, I think
mm,
it's like that. Let's try that. Let's try that. I'm not sure if it's going to work, right?
mm.
So it's values, that's the address. Remember the name of the array stores the address. So that
Yes.
address plus how many bytes? I want 0 bytes. And then here values plus how many bytes? 1 byte.
One
Which is
byte.
one. Okay, I have to say no, I have to no, I see it now. I have to say the size of an int because that's I want 4, but I want the
You
4,
want
that
four
4. Yeah,
bytes.
so size of int and then times the index. That's the formula, right?
Four times the index so that the
Yeah.
first one, it won't add anything.
It
It will
won't
add
add
zero.
anything. So that's why
Mm,
also we started index 0 for that main
mm,
reason, times 1. And
mm,
then values plus. So you don't have to do this. If you can do this
mm,
to showcase your deep level of understanding, but then you don't have to do
mm,
this. It does it behind the scenes. That's how it's calculated doing the arithmetic. So let me
mm.
see. Hopefully it should run. What's going on here? Oh, I uncommented that code, so now there's a lot going on. Where's the point? Where did I declare the point? Wait, what's going on here? No, I'm doing the wrong thing. Let me do this. Cut this and put it here. Let me comment back that code. Control Shift. There we go. So there it is. We're still back here. It should run. Hopefully it works. Okay, it's refusing. Okay, I don't want the address. I want the actual values. But then it should be working though.
Yeah, it should work now.
Am I missing something?
And values is an
Oh,
address, and
okay,
that address
okay.
plus 4 bytes.
Yeah, I see now. I forgot how to actually freeze it, but then this is how this is arithmetic that it does. So, okay, let me do this. Let me do this. Let me not index. Let's try this instead. Like this. Let's try this. Yeah. So I think I was doing it wrong. I shouldn't index because I'm using addresses, right? Yeah, let's think about it. Let's think about it carefully. Remember, we're using addresses. OX, what? It starts at 0. Let's say we have OX, and then now it's 4 and so forth, right? But then this whole thing calculates an address. But then at the end of the day, I want to get the value. So I want to point to that whole thing. So therefore, I need to put brackets here and point to that whole address that I'm calculating. You see that it will actually give me the values. It should, since now I think I have a good grasp on it now. And then let's initialize the values at least so that we know what outputs we should expect. So at index 0, set it to
You can uncomment there on top. Or is it
it's
faster for you
fine.
to type?
I just want to get used to this typing habit so that it also improves my typing speed.
Exactly.
Yeah, so let's build and run. Let's see. Fingers crossed. Don't disappoint me in front of my student.
It's gonna run.
Okay, so I think
It
it's
did the
actually
first one.
the first one did work, right? It's 100.
Yeah.
The second one, yeah, they didn't work as planned. But then this is basically how it's doing the arithmetic. If I'm not, let me see, I am doing the right thing. This is the right formula. It is the right formula. Yeah, it is. Yeah, it is the right formula. Yeah, it is. I don't know. Maybe I'm not applying it the right way, but then that's the right approach. But then we can at least get this first value that we can see. Then there's one. Then this one is a random value. Yeah, I'm using values arrays. Yeah, so don't know why
Don't
that
you
is.
think for the second one, the star should only apply to size of going that side? Maybe not apply to the, I don't know. Maybe not apply to the to values. But
Should
then what
apply.
would it do? It would get the
Oh,
address and add 4 bytes.
oh
Yeah.
yeah, yeah. I think you have a point there. But then that's going
I
to
don't
be
know. My
that's
brain is just trying to work overtime. I don't know.
that's going to be helpful. Okay, so no, I think I'm actually overthinking it. It's
Yeah,
actually, this one should be the first value, right? This shouldn't be an issue because remember it points to the
exactly.
first value. And then here I should
Yes.
just say 1 plus values, right? That address plus the size of this in bytes times that. I think, okay, this should just be times 1 obvious, just that thing plus that thing. So
Yeah, 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 yeah.
let's see if now at least we got getting somewhere.
The second value, at least.
Okay, it's still not.
Still,
So let me
I
see.
will figure it out. It's fine. We'll figure it out another time. But it was nice to try.
Yeah, I'm not sure what's going on. Should I just say +4?
Yeah.
Let's see if that, or maybe it doesn't want me to say. But then it's
+4.
still the same thing technically because size of returns 4. Still the same thing. I guess there's something that I'm missing here. Yeah, there's something that I'm missing here. But it's at index 1, or maybe I have the formula
Yeah, but
wrong.
at least the first one worked. So it's, it still
Yeah.
did it. Still did it.
Oh, okay. No. Let's do this. Plus plus. I think now I'm almost there. I'm starting to, okay, let me not say this. Let me do it this way. Plus plus. Remember, plus 1, right? It's
You
just
will
going to be,
increment, yeah.
it increment it by 1, of which I'm expecting it to be an increment of one int, which is 4
Address.
bytes.
Yeah.
That's what I'm expecting. But then let's see. Yeah, I got it.
You see you.
Yeah, I understand it. Yeah, I
You
got it.
know your stuff.
You see what I was talking about? That so that you don't say I'm lying. You see how we can only use
Uh,
addresses. Remember, this
okay,
values is
yeah.
of type int. Values is of type int.
Mm,
So when I increment it here, I'm increasing it by 1 int, which is basically 4 bytes. And then
because,
so this one
yeah.
is now at index 1, right? Which is this one. And then I
Yeah.
increment it again. So now I change, basically it's like technically increasing this one by 2, the first one by 2. Why am I saying by
Yeah.
2? Because I already incremented here and
Once
I'm
and you
incrementing again.
again,
Yeah, but then
exactly.
remember here we're just calculating the address. And then we
Mm,
dereference, we point to that address. And then Watashi was
mm.
star. You become a star like me. Yeah, so there's the value. So that you don't
Uh,
think it's magic. It's just arithmetic. Yeah, I
yeah,
was
and understanding what you're doing.
so basically it didn't want me to do that approach. That approach was actually fine. It didn't want me to do it, but then yeah, it's
Mm,
strict in that way. So this is how
yeah.
so every time when you write this, just know it's that arithmetic going on. When you're outputting at index 1, 2, 3, that's how it's doing it. It's doing that arithmetic behind the scenes, adding 4 bytes to
Okay.
the array, basically the number of bytes of each value, add that bytes to move to the next element. Yeah, this is
Okay.
something very
Okay.
advanced, and I think so far you're on the top 1% in your
The
class
right
who
track, ne?
understand. Yeah, top 1%. Yeah, you're now in the league
And
with
imagine
what?
by the time we get to this week's practical, I'll be understanding a lot more. So I
Yeah,
can't wait, Shem, as
yeah.
well for today's lesson later.
So we can also do this. I don't know if I don't think it will allow me, but we could do a for loop.
Mm-hmm.
We could do a for loop like this. Int r is equals to 0, r is less than 3, right? Because
Mm-hmm.
we have, okay, I think I actually have to start at exactly 1, if I'm not mistaken. But then
Mm-hmm.
oh no, it's fine. I think we can start at that one.
Yeah,
Plus,
it's fine
plus
as
r.
well.
Yeah, I think, let me see. Let's try to push it a bit further.
However, R I think must be 3 minus 1.
Let's see if yeah, it works. Yeah, so you see you see I can use it with the for loop like this. So I don't you see this you can write a for loop like this. Even Stung will be like, hey, this
You see?
who let this child cook? Hey, they told her to cook and she cooked. She made no mistake. She cooked. So you see,
She's not playing.
I can use my for loop in a different way. I can just use
Yeah.
arithmetic and say plus. You see, it's going to start at 0. So this is how it does the arithmetic. It starts at 0, adds that 0 to
Mm,
the address. Then after adding
mm,
0, it points to another address. I increment. I add 1
mm.
to the address, which is exactly the same thing that we're doing. Remember plus
Yeah, that you
plus.
did
Yeah. But
exactly.
then now I'm putting it in a for loop so that you see that I can just change this. And if you're feeling like more brave to show them you know your stuff, you can
You
just
can
change
put
this to
two.
size of
Oh, size.
values divided by size of values at index 0. And then they'll be like, Who let bro cook? Who let this girl cook? And then it runs very well. You don't have any issues.
This one is gonna be full marks. This one, even bonus marks.
Yeah, I'm sure that the assistants would be like, what's the meaning of this now? And then
Yeah.
when they're busy taking there, you like show it to show it to Dr. Stung, show it. Yeah, you see, there it is. Okay, obviously something's not right, but then
Plus
yeah,
one, probably.
yeah, there's
Yeah.
okay, let me see. Yeah. It checks if it's less than or equals to this size of. Oh yeah, I think I see now. Let me see. So you need to be very careful here. That's the thing. So you
Size
need
of
to
values is 3 divided by the size
no.
of.
mm, uh, let me call it S. I think I'm remembering something here. Let me find. Okay, let me find the way this thing has been implemented. Hi, why is not showing? Okay, but then let me do this. I think now it should be fine because it's a complicated thing. But then if it works now, then it was that issue. Or it's still not that thing. But then yeah, you were close. So I guess no. How many elements does it return here? It should return 3. And I'm saying less than 3, which is okay. I don't know. But then yeah, you should be working. But then you could see you can make your thing advanced to show them that you really do understand what you're doing. You're not doing ComSci by chance. Yeah, so you see all of this one line, you need to have a deep level of understanding of how arrays work. So you can do this and show them like, I know my stuff. You display the image like this, and then they're like,
Exactly.
this is the first time we've
But
seen code like this. Even the top achiever students they've never
they don't do
implemented code
this.
like this.
Yeah, but you think we're still on track to be able to make it to the practical explanation by
Yeah,
4th Friday? You think we're still good, ne?
I think we're a bit behind because I also wanted to explain record structures, but then since we're done with the pointers and arrays, we can now start with record structures, and then after record structures, I think functions here, are you fine with the functions? Because the only thing with functions that's confusing is the thing of having a pointer and an address at the same time. That's the only thing that I can say it's a bit confusing.
Yeah, true,
Yeah, but then
true,
the rest
true.
is fine because it's
Okay.
functions. You just simply write the return type, what should be returned, the name of the function, and then X and Y. But then computers are very strict. You need to specify the data type of each of the parameters, what type and
Yeah,
you should expect. So it's int X and int Y. And then you return the sum, which is X plus Y. That's pretty much
exactly.
functions. There's
That's
nothing
pretty much
too
it.
complex.
Functions I'm good with.
Yeah, so
Functions I'm
the main
good
thing you
with.
needed to understand is the fundamentals, like your pointers, your variables, memory, how does it work? Why new, when you say new, all those things.
What
Obviously,
does it
I
mean?
forgot to delete here. You're supposed to delete.
Mm,
Remember now we're using this whole block because we use the block to allocate. So I must delete that
yes.
whole block. And then
Yes, yes,
remember we must
yes.
cut the ties, that line, that pointer. We must cut
Now
it so
pointer.
that we get a proper error like segmentation fault so that we know, oh, I am pointing to a null pointer. So I've deallocated the memory perfectly fine.
Okay.
Yeah, so that's it for today's session. I'll send you the code and the images.
Thank you so, so much. And then I just need to remember that new keyword is used when you want to allocate new memory, reserve new memory in the heap,
Yeah,
right?
in the heap.